Well, hello there, everybody. Hope you guys are having a wonderful day. It's pretty exciting. We're going to learn about exponents. Oh, dang. Your dream comes true. Hey, I want you to be successful. To be successful, you have to be a good student. One of the tricks about being a good student is that you have to understand that learning is an active engagement. It requires willing participation. It's not a passive thing. It is difficult. You have to struggle through some misunderstanding and confusion to get to be where you want to be. But it's okay because it's something that you can do. Might be uncomfortable, but once you get, once you become familiar with how it works, it's actually good, enjoyable. The challenge could be fun. So anyway, I mention that because this is a video. Videos are passive. You can sit there and watch. There's almost nothing more passive. So I'm putting this together to help you be a better student. So to do your part, you need to be taking notes, writing questions, pausing videos, trying problems, all those kinds of things. Especially pausing the video when you have a question. You write down your question, replay the video when you find the answer to your question. Maybe it's not even in the video, but when you do find the answer to your question, you go back and you answer it. You write down the answer in your notes. So anyway, let's get started. Here we go. We're going to be talking about exponents today. Here's the thing. Math is a written language. Now, exponents are just a notation for writing repeated multiplication. So first of all, check this out. Do you know how, let's see here, we could have 5 times 3, and that would be 3 fives added. That'd be 5 plus 5 plus 5. So in a way, what multiplication is, it's repeated addition. But it's a notation, it's a shorthand way of writing repeated addition. Now that might not seem like it makes any sense yet. You might not see where that is going, but check this out. This is where it's going. Do you see? 5 to the third. That would be 5 times 5 times 5. That is an exponent. And the exponent tells you how many times that the base is being multiplied by itself. Do you see? So here's the base. There are 5. And you see how there are 1, 2, 3 of them, and they're all multiplying? That's what it means. Now, one of the beautiful things about exponents is that you don't actually have to do the arithmetic. You don't actually have to figure out that that's 125. This is so much easier to write. Now, that one was pretty easy, and you might actually even know the fact, but suppose you had something like this. 5 to the 14th, that's a ridiculously large number. It'd take you forever to write it, and it wouldn't make any sense. Instead, we could just write it like that, you see? So that's how exponents are used. That's why we write them like this. It's a shorthand way of writing repeated multiplication. It makes life easy. So now the thing is with multiplication is you can change the order, and the result is still the same. 5 threes added is the same as 3 fives added. But that doesn't work for exponents. For exponents, the exponent is how many times. This describes how many times the base is being multiplied by itself. And yeah, so that's kind of how that works. So now check this out. What if you had something like this right here? What if you had, oh man, this is going to get a little tricky right here. What if you had something like this? What if we had, let's say, 2 to the third, yeah, times 2 to the second. And what if we compared that to this? 2 to the third plus 2 to the second. Well, let's see here. Oh man, we're gonna get some beautiful fancy colors going here for you guys. Oh man, we got some red, pink, light blue. So check this out. See this 3 right here? That means there are 3 of the base. And the base is, oh no, this pen doesn't work. Look at that. Ah, dang. Bye, pen. Anyway, of this, 3 of those. So that would be 2 times 2 times 2. Now you see this right here says they are multiplying still. This says there are 2 more of the base multiplying. So that would be 2 to the 5th. You see? Now there are a series of rules that they show you. But the rules all come from this basic notion right here. They all come from this right here. This is exactly where they come from. So you can actually forget the rules. You probably will forget the rules. But if you remember the idea, well, that's something, once you understand the idea, you're going to remember it. Okay, moving on. This right here, check this out. This is a little different. You can't actually add these together with the exponents. It's true the bases are the same, but these aren't the same things. So these are apples and oranges. This is 2 times 2 times 2 plus 2 times 2. Those aren't the same thing, so you can't add them together. You could do the arithmetic. You could follow the order of operations PEMDAS, right? But yeah, you can't add those bases together. So this would not be 4 to the fifth or anything like that. That's just all totally that doesn't work that way, unfortunately. But so if the bases are the same and you're multiplying, well, the shortcut, you see, the shortcut is you actually add those exponents. So that's where this rule comes from. That's where, like, you'll see this, or you'll see it written something like this. And the reason that is just like this right here. So I remember when I was a math student, these things would confuse me. I'd see these rules and they'd confuse me. So what I would actually do is I'd have to actually plug in numbers like this that I could figure out myself, and then I would see how it would work. So this is like saying if A and A are the same, then you can add those exponents. So like if you had something like this, why don't you try this one? See what that equals. Maybe you can just say the answer. Maybe you need to write it down. If you do, pause it. Here's what it is. You ready? I'm going to do it now. If you didn't pause it yet and you want to, hurry, hurry. 5 to the 10th, right? 7 plus 3 is 10. Yeah. Whereas this is different. Let's say we had 7 to the 5th times 3 to the 5th. Well, those you cannot combine with exponents. You'd have to do the order of operations. See, exponents go before multiplication. So you'd actually have to figure out what this number is, figure out what this number is. Because this is just a single number. I don't know what it is. It's not written out. It's 7 times itself 5 times. This is 3 times itself 5 times. Really big number too. So yeah. Anyway, this one the bases aren't the same, so we cannot add those exponents. The reason you can do this is because remember, exponents are repeated multiplication. Multiplication, you can change the order, so you can actually change the order of these, and that's what you end up with. That's what we did here. Do you see? Anyway, let's move on. Check this out. Let's do something like this. What if you had, let's say we had 2 to the 3rd to the 4th power. Here's the thing that's kind of weird about this. I want to help you so that you can really read this and understand what it means. So you know how with an exponent you have a base and then you have the exponent, right? Well, this is strange because it has two exponents, right? We have a 3 and we have a 4. So it turns out for the 3, the base is a 2. But because of these parentheses, for the 4, the base is 2 cubed. So what this really means, it means 2 cubed times 2 cubed 4 times. Do you see? That's what it means. That would be, now, check this out. We could write it all the way out, but the thing we just learned, if the bases are the same, you can add the exponents, right? So the base is 2. That'd be 3, 6, 9, 12. The rule, you see, is often like this. And that's absolutely true. That's how it works. Now, where that can get confused, well, here, before we get into where that can get confusing, how about you try one? Let's do 5 to the 3rd to the 6th. Try that one. Go ahead and write it down. Pause the video. Okay. That's 5 to the 18th. Do you see? There's 6 of these all multiplying together. And so if you wrote all of that out, each of these 6 would have 3 5s. That would make 18 5s multiplying. That's what that means. This means 18 5s multiplying by themselves. So it would be 5 times 5 times, 18 times. Right. Okay. Now, here's where this gets confusing. Check this out. Let's say we had 3 squared x to the 4th to the 5th power. Oh man. Now this is kind of tricky. This is the same as 3 squared to the 5th times x 4th to the 5th. Now that's not a step. This is not a step. I would never write that. But I mention it because that's what you should see. That's what you should recognize. You should recognize that the base for this 5 is actually 3x squared 3 squared x to the fourth, 3 squared x to the fourth. So this would actually be like this right here. You can't distribute exponents really. That's not what we're really doing right here. What we're really doing is this. This is what's really happening, but this is usually how we write it, and we get 3 to the 10th, x to the 20th. You see? The reason you can't is because if you had something like this, you can't say that's x cubed plus 2 cubed. That's not how it works. Because what this really means, it means the base times itself 3 times, so that'd be x plus 2 times x plus 2 times x plus 2. And I bet you don't know how to do that yet. But you'll learn that in this class later. But the thing I want you to be aware of is that the exponent means the base times itself that many times. And when you have parentheses, everything inside the base, or everything inside the parentheses is the base. So this is the base right here, x plus 2. So you can't distribute like that. That's a nope. That's a no-go right there. That makes a sad panda. Okay, almost done. One last thing. What if you had something like this? This is actually where people really get into trouble. See, right here, two questions for you. First question is, what's the base for the 5? The exponent of a 5. What's the base for the 5? Would you guys agree that the base for the 5 would be 3x squared? Right? So this would really be 3x squared, 3x squared, 3x squared, 3x squared, 3x squared. I'm glad I didn't do a 12 there. I'm glad I only did a 5. And they'd all be multiplying, correct? Yeah. Okay, here's my next question for you. For the x, what is the exponent? You could say it's 2, you could say it's 10. You could also say, yeah, you could say it's 2 or 10, depending on how far you simplified it. But if you forget about that right there, let's just cover it up. The exponent for the x is a 2, right? That's an x squared. What's the exponent for the 3? Well, it's actually a 1. Because anytime you have a number, like let's say we had the number 7, and that's it right there. Well, we don't need to write the exponent 1. That just means there's one of them there. That's it, just one. So we never write the exponent of 1. There is an exponent of 1 right there. And so this would really be 3 to the 5th, x to the 10th. Don't forget about that right there. That's what people always mess up. Another thing that people do is they say this. Oh, that's a sad thing right there. That's so sad. All right. One last example. I probably said one last time. But let's say we had something like this. Oh man, that's weird, right? 3x squared divided by 5 cubed, all of that to the power of 4. Well, look, the thing is, we have this rule right here. Every exponent can be multiplied by this external exponent, right? So here the 3 has an exponent of 1, so that'd be 3 to the 4th, right? Because you're going to multiply. This would be 8, because 2 times 4. This would be 12. And that's your answer right there. Everything inside gets multiplied by the exponent. So to summarize, first of all, number 1, exponents are just a shorthand way of writing repeated multiplication, so you don't have to write out some big old ugly thing, right? Just like multiplication is repeated addition, exponents are repeated multiplication. You see? It's a key concept right there. That is actually the idea. That's the thing you got to know. You know that, the rest of it, the next 4 lessons come from that big idea. So if you know this, the rest of it's going to make sense. But when you're doing your practice, always revert back to this, okay? So now, we also learned that if the bases are the same, right? We have a base, we have an exponent. If the bases are the same and you're multiplying, you add those exponents together. And the reason why is because they're multiplying and exponents are repeated multiplication. So this is just multiplication and then more multiplication of the same thing. So if they're the same, you can. If they're different, you cannot. So if you had 2 to the 3rd times 3 to the 4th, you can't do anything there. There's nothing you could do other than actually carry out the arithmetic using the order of operations. So the shortcut is this. If their bases are the same, you can add those exponents together. The next thing we learned is that if a number is just written by itself, the exponent's 1. We also learned that if you raise it, the way we say it is you raise a power to a power, you can multiply those exponents. Do you see? And the reason why is because, like if you look at this one, 2 cubed to the 4th, this 4 means that there are 4 of the base multiplying together. So there are 4 of these. And as we just learned, if the bases are the same, and you're multiplying, you can just carry out that addition right there, because this is just more multiplication. This is 3 of them multiplying times 3 more of them multiplying. Well, that's 6 total multiplying. Well, there's 3 more of them multiplying. Well, that's 9 multiplying. There's 3 more still multiplying. That's 12 multiplying. Do you see? So you raise a power to a power, you can multiply. The thing you got to be careful with is this kind of thing when the base has an exponent that's 1, because there's no exponent written there. A common thing to do is to distribute like this, and that's totally wrong. The truth of it is you're not actually distributing the exponents. That's not really what's happening. You're just using this shortcut right here for multiple bases. That's what we're doing. So you get something like this. 3 to the 1, x squared, 5 to the third. All of those exponents get multiplied by 4 to get this. Man, a ton of information. Hope it's been helpful. Uh, oh, by the way, man, you guys are looking good today. Hope you have a good day. Talk to you later.